Euler's method. I'll explain you Euler's method with the help of an example. So suppose we are given a differential equation dy by dx is equal to y, and we are given initial condition that for x naught is equal to 0, the value of y is equal to 1. Okay, so for this question we know that the solution of this question is y is equal to e to the power of x. So first of all, let us see what is the graph of y is equal to e to the power x like. So here's a graph for y is equal to e to the power of x. Okay. So now we'll start with the problem. So we have to find the solution of this uh, question with the help of Euler's method. Okay, now so I have made a table over here. So in this table I have three columns with the values x, y and divided by dx. So over here we know that initially the value of x is equal to 0, and for this the value of y is equal to 1. The initial condition is given in the equation. Okay, so now using the equation dy by dx is equal to y, we can find out the value of dy by dx, which will be equal to 1, same as that of y. Okay, so now if we plot this line in our graph, then what we'll get is something like this. Okay, so we can see over here that the blue line is for the equation x is equal to y minus 1, where the value of x naught and y naught is 0 and 1, and the value for dy by dx is 1. Okay, so now to solve this further, we will zoom this image. So we'll take interval in this Euler's method. So over here I have taken the interval of 0.5. Okay, so now we'll find the value of y at when x is equal to 0.5. To find this, we'll first label the points. So as you can see over here, we have LP, then we have L1, P1, and we have this point R1. We have to find the value of P1. So we'll use this tangent line to find the value of P1. So basically the blue line is the tangent to the curve e to the power x. So the next point will be 0.5, and corresponding point we'll consider it to be point P1. So to find out the value of P1, we'll use this formula. So now, so we have this tangent line to the curve y is equal to e to the power x. Now suppose this angle is theta, okay, and we know that this is our y naught, and we have to find out the value of y1 now. Fine. Now to find the value of y1, we can say that y1 is equal to L1p1, where L1p1 is equal to L1r1 plus r1p1, and L1r1 is equal to y0. So we can write it like y0 plus r1p1. Now this r1p1 is equal to PR1 tan theta, right? And we can write PR1 as h, since we are considering the difference in the interval as h, that is 0.5. So PR1 as h, and tan theta is dy by dx at point P, that is slope of the tangent line at point P. Okay, so using this formula we can find out the length of y1. So to find y1, we have we are finding the value of y at 0.5. So at 0.5 the value of y will be y naught, that is 1, plus h, that is 0.5, into dy by dx, that is 1. So 1 plus 1.5, 1 plus 0.5, that is 1.5, and the value of dy by dx will also be equal to 1.5 since dy by dx is equal to 1. Now next we have to find the value of x at 1. So now what we will do is, again we will go to our graph. So over here, now we will draw the line y minus 1.5 is equal to x minus 0.5 into 1.5 using these values, the values of the second rule. So let me raise this first line for better clarity. Okay. So now this is the tangent line at point P1. Okay, now so I will find the value of y at this tangent line when x is equal to 1. So the value of y when x is equal to 1 I will find using the same formula. So my formula was, so using the same formula I will find the value of y2. So over here this is my y2. Okay, this is my y1 and this is my angle theta. So I can write y2 is equal to L2P2, right? And L2P2 is equal to L2R2 plus R2P2, where L2R2 is y1. So this is y1 plus R2P2 can be written as P1R2 tan theta. Right now P1 R2 is the interval h and tan theta is dy by dx, that is the slope of the tangent line at point P1. Okay, so now the value of y2 using this formula will be uh, y1 is our 1.5 and then plus, okay, so using this formula we'll find the value for y2. The value of y2 will be 1.5 plus the value for h is 0.5 and multiplied with the value of dy by dx at p1, that is 1.5. So we'll get 2.25. Okay, and the value for dy by dx will also be 2.25, same as x. Okay, so when we plot this tangent line, what we'll get, let us see now. So when we plot this, we'll get this line. Okay, so now next point we have to consider is when x is equal to 0. When x is equal to 1.5. So when we use the same formula to find the value of y, this is 1.5, what we get is 3.375 and divided by dx will be 3.375. So the tangent line will be this. Okay, purple one. So we can see that when when x is equal to 2, when x is equal to 2, this lines give us this solution as somewhere near about 5 point something, right? whereas the value for the curve is near about 7 point something. So this is the error, and we get the approximate answer. So the smaller we take the value for h, that is the smaller we take the interval, the more approximate answer we get for this.